All right, so what I want to do right now is I'm going to go over some rules that we've already covered before. And it's going to be a series of videos of all the derivatives that we have not, or that we've actually covered, but just so that you guys can start refreshing your memory. So the first one we're going to go over is called the power rule, and you guys are pretty familiar with that. It's the first one we've gone over. Okay, the power rule, and this is note card number 10. Okay, and you guys should already have it in your notebook in your the packet that I had given you before. So in this note card, it gives you some subcategories. So the first one is the derivative of any constant is equal to 0. So if you guys remember, let me give you an example. Let's say y equals to 4. So 4 will represent the c, okay? C for constant. And if you graph c, if you graph y equals 4, you get this horizontal line. And this is y equals 4. And the slope of any horizontal line is 0. So this is an example, the slope of that line is 0. So that's why the derivative of any constant is 0. Okay, the second one is the power rule itself. So here is the derivative of a term that has this polynomial look. Okay, so so when you take the derivative of anything that's in this form, you're going to use this rule nx to the n minus 1. Okay, that one's pretty basic. The next one is like number 2, but it throws in a constant in front, so it's kind of like 1 and 2 mixed together. But don't get confused and think that your answers here is going to be 0, because what you need to do when you see anything that's in this form is you take the derivative of your function first, and then you can multiply or rewrite the constant, and then once you finish taking the derivative, you multiply it out. So this is basically what it's saying, okay? And then the last one that's on here is the sum and difference rule, okay? So the sum and difference rule basically says that if you have, this just gives you two terms, right? But if you have like a series of terms like x, y, z, or even more than three, what you can do is you can take the derivative of them individually, okay? And then if you can, you can combine them in the end, okay? But basically what this was trying to tell you is that you take the derivative of them individually without having to worry about them as a whole, okay? All right, so that's that right there. We're going to go over the examples that are on note card 10. So the first example, it says if you have x to the 3 halves, then what is f prime of 4? Okay. So what we're going to do is first, we need to first take the derivative before we even plug in the 4. So the derivative of this requires us to use example 2 right here, this rule. So basically what it says, if you have x to the some power, you move that power to the front as a coefficient. So we're going to move 3 halves as a coefficient. And then we're going to take away 1. Now 1 can be written in many forms, okay? So for us to subtract these two, I'm going to write it as 2 over 2. Eventually you guys will be able to do this without even having to write it down, but just for the sake of writing it down so you guys can refresh your memory, I'm going to go ahead and put it there. All right, so then we subtract these two, and then we get 1/2, and everything's rewritten, okay? So technically this can be, I mean, you can leave it like that, but it starts getting a little bit more complicated once you start seeing like other types of fractional powers and you have to start evaluating it. So just to get in a habit of it, I'm going to go ahead and simplify it, okay? So I'm going to get 3 times the square root of x over 2. So now I'm going to go ahead and plug it in, okay? So I'm going to get 3 square root of 4 over 2. So we get 3 times 2 over 2, and this reduces to a 1, so we're just left with a 3. So my answer for that one is 3, okay? All right, the second example is f of x is equal to 1 over 2 cube root of x squared. So now, in order for us to take the derivative of this type, it needs to look like this. So that means it needs to be in the numerator. This variable needs to be in the numerator, and it can't be in radical form. So radical form means that it has a root, okay? So I'm going to go ahead and rearrange this. I'm going to put x to the negative 2 over 3. So the 2 because that's the power, and the 3 is the denominator because that's a root. Now it's ready to go, okay? So I'm going to go ahead and take the derivative. And I'm going to go ahead and rewrite the 2. So now look, this one is in this third form here. So it has that constant, which is a 1/2. So I'm going to go rewrite the 1/2 and then take the derivative of the function itself. So move this to the front. So times negative 2 over 3 x. And then we take away 3 over 3. So once again, I'm going to rewrite it. And then I'm going to simplify. So I'm going to reduce this. It becomes negative 1/3. And then I'm going to go ahead and combine these. So I'm going to get negative 5/3 as my power. So rewriting this. So once again, technically this is the correct answer. Okay, but I'm going to rewrite it so I can practice. So negative 1 over 3. All this goes to the bottom because it's negative power. The 3 is the root, so it's going to be the cube root to the 5th power because the 5 is the denominator. Okay, so technically both of these are your answer, but it's good practice to rearrange it. The third one is a of t is equal to negative t to the 4th over 2 plus 3t to the 3rd power minus 2t. All right, so now we're going to take the derivative. So once again, we're going to use this sum and difference rule where we're going to take the derivative of each term individually. So I'm going to take the derivative of this term first. So just a regular power rule, move the 4 to the front, take away 1 divided by 2, plus take the derivative of this individually. So 3 times 3 is 9, take away 1 is 2. And then the other term, the derivative of this is 2. Okay, so once again, technically this is your answer. But just for good practice, let's go ahead and reduce it. We get negative 2t to the 3rd power plus 9t squared minus 2. And bam. So this is an answer, and also this is an answer. Okay, so both are acceptable. All right, so the next and final one is, it's written a different way. So it has the derivative of 1 over x cubed minus 1 over x plus x squared. And they want us to evaluate it at x equals negative 1. Okay, so the difference between this one here and the ones we've done before is the fact that these all have, they're in function notation, whereas this one isn't. Okay, so it's important for us to keep the notation in so that it makes sense. So I'm going to rewrite the dy, the derivative of x. Okay, so the derivative of this function, I'm sorry. So make sure you rewrite this because it's mathematically correct. And then once I rewrite it, I'm going to go and rewrite this so that it can be ready to take the derivative. So it's going to be x to the negative 3 minus x to the negative 1 and then plus x squared. Okay, so now it's ready to take the derivative. Okay, so now I'm going to go ahead and take the derivative of this. It's going to be negative 3x to the negative 4 because we take away 1 plus, because negative times a negative is a positive, x to the negative 2 because we take away 1 plus 2x. Okay, so now this is the derivative, but now I got to plug this in. So in order for me to keep the notation so it can look nice, I'm going to go ahead and rewrite either this one, it doesn't matter. I'm going to write the top one. I'm not going to take the derivative anymore. I already know what it is. But then I'm going to put a bar, x equals negative 1, because this tells me that I'm taking the derivative and plugging it in. So now I'm going to go ahead and plug it into the portion that I took the derivative of. So one more thing that I forgot to mention is make sure that you rewrite this, because while this we can probably think about what the answer is going to be, because it's not that difficult for us to plug in the negative 1. But let's go and rewrite it so it can be easier and make it a good habit. Okay, so it's going to be, this is going to be rewritten as negative 3 over x to the 4th plus 1 over x squared plus 2x. So I'm plugging this negative 1 into this portion here. Okay, so it's going to be negative 3 over negative 1 to the 4th plus 1 over negative 1 squared plus 2 times negative 1. Now, once again, eventually you guys are going to be able to do a bunch of this stuff in your head. So I don't, like this one, I mean, whenever this is even and you have a negative in here, even power, your answer ends up being positive. So, and it's a 1 too, so your answer is just going to be the numerator. This one's going to be a positive one because negative 1 squared is just 1, 1 divided by 1 is 1. And this ends up being a negative 2, so your answer is negative 4. Okay? So what I'll do next is I'll make another video over some of the other problems that probably look a lot more complicated than this, but the purpose of this is for us just to practice and make sure that we have these down, because when we start doing finding the max and mins and related rates, some stuff that you haven't gone over, that stuff is going to be easier to understand, and we won't have these types of questions or these type of problems in our way. Okay, so make sure you guys tune in and you guys practice.